Hi everyone, my name is Irene, and today I'll be presenting a credit of the paper entitled Implementation of Simple Linear Regression for Predicting Students' Academic Performance in Mathematics by the author Hassana and her colleagues. This presentation will discuss the paper's finding, evaluate the suitability of the algorithm used, propose an alternative algorithm, and reflect on an ethical concern regarding the deployment of educational prediction models. So now let us have an overview of the paper. Selected paper focus on predicting students' academic performance in mathematics. The authors used the student performance dataset from the UCI Machine Learning Repository, which contains data from 395 Portuguese secondary school students. The objective of the study was to identify factors that influence academic achievement and predict students' final mathematics grade. Several variables were examined, including study time, valence, free time, absence, and final grades. The authors applied simple linear regressions to analyze the relationship between these factors and students' academic performance. As I said just now, the algorithm used for this paper is linear regression. So why the author select this algorithm is because the target variable, which is final mathematics grade, is a continuous numerical value. Linear regression is easier to implement and easier to interpret so that the educators can understand how changes in one variable may influence student performance. The study also reported that RMSE value is 1.148 and MAPE value is 9.82%. Among all variables tested, the number of previous valence was found to be the strongest predictor of academic performance. The author also found that this variable explained that approximately 63.8% of the variation in students' final grades. So why I choose this paper? It is because this paper is closely related to our project because both studies focus on predicting student academic performance. In our project, we use the student performance factor dataset and perform EDA. Our EDA showed that our study, attendance, and previous score were the most important factors that influence exam score. We also observed that some relationship in the dataset that we chose may not be perfectly linear. So this observation is really important because it helps us to evaluate whether linear regression is the most suitable algorithm for educational prediction tasks. The use of linear regression has several strengths. First, it's really simple and highly interpretable. It allows fast training time because it is easy to explain to teachers and school administrators. However, there are also limitations. Linear regression assumes that the relationship between the predictors and the target variables is linear. But in the real world, student performance is influenced by many interacting factors such as motivation, attendance, study habits, and family support. All these relationships may be complex and non-linear. So, although linear regression provides useful insight, it may oversimplify the patterns present in educational dataset. So, this means that some important relationship between variables may not be fully captured by the model. The alternative algorithm that I propose is random forest regression. Random forest is a learning method that combines multiple decision trees to make prediction. Unlike linear regression, random forest can capture non-linear relationship and interactions among variables. This makes it particularly suitable for educational datasets where many factors work together to influence student performance. The main advantage of random forest is its ability to achieve higher predictive accuracy and handle complex patterns. However, compared to linear regression, random forest is less interpretable and requires more computational resources. Let us move on to ethical reflection. One ethical concern related to educational prediction system is student labeling. If a model predicts that a student is likely to perform poorly, educators may treat that student differently. This can lower the student's confidence. For example, a student he or she is identified as at risk may receive fewer opportunities because teachers assume that the student will struggle. To address this issue, prediction models should only be used as decision support tools. Final educational decisions should involve teacher judgment, student discussion, and additional contextual information. School also need to regularly evaluate the fairness of prediction models to reduce potential bias. In conclusion, the review paper demonstrates that simple linear regression can be used successfully to predict students' academic performance. The model achieved good prediction results and identified previous failure as the most influential factor. However, the algorithm has limitations because it assumes linear relationship and may not fully capture the complexity of educational data. Based on our EDA findings, random forest regression could be a suitable alternative because it can model nonlinear relationships and interaction among variables. Finally, ethical issues such as student labeling must be carefully considered before deploying predictive systems in educational settings. And that's all for me. Thank you.